NEC Section 240.85b specifies requirements for circuit breakers used in panel boards within commercial and industrial installations. This section of the National Electrical Code mandates that circuit breakers with a rating of 100 amps or more must be of the bolt-on type. This requirement is specifically applicable to panel boards used in commercial and industrial settings. The reason for this requirement stems from safety and reliability considerations. Bolt-on circuit breakers offer a more secure and robust connection compared to plug-in or clip-in breakers, especially in environments where vibration, physical stress, or high fault currents may be present. A secure connection is critical for maintaining the integrity of the electrical system and preventing potential hazards. Firstly, let's define what constitutes a bolt-on circuit breaker. A bolt-on circuit breaker is designed to be physically bolted to the busbar or the mounting structure within the panel board. This mechanical fastening ensures a firm and consistent electrical contact between the breaker and the power distribution system. In contrast, plug-in or clip-in breakers rely on spring-loaded clips or pressure contacts to establish the electrical connection. While plug-in breakers are suitable for many residential and light commercial applications, they may not provide the same level of long-term reliability in demanding industrial environments. Secondly, the 100 amp threshold is significant. Circuit breakers rated at or above 100 amps are typically used to supply power to larger loads such as motors, HVAC systems, and heavy machinery. These loads can draw substantial currents, particularly during startup or under fault conditions. The increased current flow places greater stress on the electrical connections, making a secure bolt-on connection essential for preventing overheating, arcing, or premature failure. Thirdly, the distinction between commercial and industrial installations is also important. Commercial installations generally refer to businesses and retail establishments, while industrial installations encompass manufacturing plants, factories, and other heavy industrial facilities. Industrial environments often involve harsh conditions such as exposure to dust, moisture, vibration, and extreme temperatures. These factors could accelerate the degradation of electrical connections, increasing the risk of loose connections and electrical faults. Fourthly, the NEC mandate for bolt-on breakers in these environments is a proactive measure to enhance safety and prevent downtime. Now let's delve into the practical implications of NEC Section 240.85b. When installing or upgrading electrical systems in commercial or industrial buildings, it's crucial to verify that all circuit breakers rated 100 amps or more are of the bolt-on type. This requirement applies to both new installations and replacements of existing breakers. When selecting bolt-on breakers, it's essential to choose models that are specifically designed and rated for use with a particular panel board. Different panel board manufacturers may have unique designs and connection methods, so it's important to ensure compatibility. The breaker should fit securely and make proper contact with the busbar. Proper installation of bolt-on breakers is critical. The bolts or screws used to fasten the breaker to the panel board should be tightened to the manufacturer's specified torque. Over-tightening can damage the breaker or the panel board, while under-tightening can result in a loose connection. A calibrated torque wrench should be used to ensure that the correct torque is applied. Regular inspection and maintenance of bolt-on breakers are also important. Over time, the connections can loosen due to vibration, thermal expansion, or corrosion. Periodically inspect the breakers to ensure that the bolts are tight and the connections are clean and free from corrosion. If any loose connections or signs of damage are found, the breaker should be replaced immediately. Now let's examine the potential consequences of non-compliance with NEC Section 240.85b. Using plug-in or clip-in breakers in applications where bolt-on breakers are required can create several safety hazards. Firstly, a loose connection can cause overheating, which can damage the breaker, the panel board, and the surrounding wiring. Overheating can also lead to insulation breakdown and short circuits. Secondly, a loose connection can create arcing, which is a dangerous electrical discharge that can ignite flammable materials and cause a fire. Arcing can also damage the breaker and the panel board, potentially leading to a catastrophic failure of the electrical system. Thirdly, non-compliance with the NEC can result in fines, penalties, and legal liabilities. Electrical inspectors are responsible for enforcing the NEC, and they can issue citations for violations. In the event of an electrical fire or injury, non-compliance with the NEC can also be used as evidence of negligence, potentially leading to lawsuits and significant financial losses. Now let's consider how NEC Section 240.85b relates to other sections of the NEC. Firstly, NEC Section 110.3b requires that all electrical equipment be installed and used in accordance with the manufacturer's instructions. This means that bolt-on breakers must be installed and maintained according to the manufacturer's specifications. Secondly, NEC Section 240.4b provides rules for overcurrent protection. This section specifies the maximum size of the circuit breaker or fuse that can be used to protect a particular circuit. The overcurrent protection device must be sized appropriately to protect the wiring and equipment from overload and short-circuit conditions. Thirdly, NEC Section 408 covers the installation and construction of panel boards. This section provides requirements for the physical construction of panel boards, including the spacing of conductors, the grounding of the enclosure, and the labeling of circuits. Panel boards must be installed in a location that is accessible and protected from physical damage. Now let's discuss some common misconceptions about bolt-on breakers. One common misconception is that bolt-on breakers are only required for very large electrical systems. While it's true that bolt-on breakers are typically used for high current applications, the NEC requires them for all breakers rated 100 amps or more in commercial and industrial panel boards, regardless of the size of the overall electrical system. Another misconception is that bolt-on breakers are more expensive than plug-in breakers. While bolt-on breakers may have a slightly higher initial cost, the increased reliability and safety they provide can more than offset the cost difference over the long term. In addition, the cost of downtime and repairs resulting from a failure of a plug-in breaker can be significantly higher than the cost of using a bolt-on breaker. Another misconception is that bolt-on breakers are difficult to install. While bolt-on breakers require a slightly more involved installation process than plug-in breakers, the process is still relatively straightforward and can be easily mastered with proper training and tools. The key is to follow the manufacturer's instructions carefully and use a calibrated torque wrench to ensure that the bolts are tightened to the correct torque. To summarize, NEC Section 240.85b mandates the use of bolt-on type circuit breakers for commercial and industrial panel boards when the breakers are rated 100 amps or higher. This requirement is based on safety and reliability considerations, as bolt-on breakers provide a more secure and robust connection compared to plug-in breakers. Compliance with this code section is essential for ensuring the safety and reliability of electrical systems in commercial and industrial buildings. Failing to comply can lead to overheating, arcing, fires, and legal liabilities. When installing or upgrading electrical systems, it's crucial to verify that all circuit breakers rated 100 amps or more are of the bolt-on type and that they are installed and maintained according to the manufacturer's instructions. Regular inspection and maintenance are also important for ensuring that the connections remain tight and free from corrosion. By following these guidelines, you can help to prevent electrical hazards and ensure the safe and reliable operation of your electrical system. Remember to always consult with a qualified electrician for any electrical work and to adhere to all applicable codes and regulations. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice.